Hello guys, today our topic is CBSE trigonometry exam questions. So in some questions we have to prove it, and some we have to simplify, and some we have to evaluate the values. And you must obviously remembers the formula before that, because we are using the old formula to solve these kind of questions. So now our first question says that simplify the following expression. This is sine cube of theta plus cos cube of theta over sine theta plus cos of theta. So this is our question. We have to simplify that value. Before that we must know the formulas of that, how to solve the cube root of that value. There's our the cube's values comes up in there. So how we can solve it? There are two formulas, in the positive, in the negative. Just like I write down in here, if I write down any value, just like a cube plus b cube, there is a one thing, and the second is a cube minus b cube. That's the second formula. If the value is in positive form, then what formula we can generate that one? If that is a positive, so a plus b positive. If that is negative, that becomes a minus b negative. First, if that is a positive, then first value is positive, and then if the negative, the second value should be a negative. So now we are proving that one. If that is a positive, so that becomes a square minus ab plus b squared. When it comes in a negative, then a squared plus ab plus b squared. These are the formulas, and you can simplify these formula as well. I can write down in here, just like in here. As you know that that's a two brackets, you have to remember these formula to solve that values. Just like in here, you know that how we can solve the brackets. If we solve these brackets, so that will be equal to that value. If just write down, when you solving bracket, this first value multiply with the first, then second, and then third. Same as it is, the second value multiply with the first, then second, and then third. If we multiply that value, so let's see, I'm gonna do that. So the first value that becomes, I'm gonna do that one, a times a, that becomes a cube. A times ab, that becomes minus a squared b. A times the third value, that's a positive a b squared. That's one thing done. Secondly, b times a squared, that becomes plus a squared b. B times second value, plus minus give you minus a b squared, plus and plus, that becomes plus b cube. Now you can see in here which value we can cancel. A square b, that's negative. A square b, that's positive, that cancel. A square b square, that's positive. A b square, that's negative, that's also cancel. What's the remaining? A cube plus b cube. So we are using that formula to simplify that expression. So now you can see in here you have to remember these formulas. This is the positive. If the positive comes up, then plus and minus. If the negative comes in, minus and then plus in here. So I can remove in here that value. And you can tell them by using, you can say that by using that formula. So instead of that one, what value we can write down instead of that? That becomes sine theta plus cos of theta, right? And secondly, we can write down in here sine square theta minus sine theta cos theta plus cos square theta over what is value in the bottom, sine theta plus cos of theta. So that cancel with that one, right? What's the remaining? Only remaining that value. Can we write down that value as it is? Sine square theta and then plus cos square theta, and we put negative values after. Why we have done this? Because you know that this thing sine square plus cos square is equal to 1. That's why. So 1 minus sine theta cos of theta. This is the answer. This is our simplification. We have done that. So we are moving to the second one. The second question say that prove that tangent one minus cotangent theta plus cotangent theta over 1 minus tangent theta equal 1 plus tan theta plus cotangent theta. We have to prove that one. So before that, we have two sides. This is left hand side and this is right hand side. We can pick one of the side and then prove it to the other one. So now we are selecting left hand side in here. As you know that, one more thing I want to tell you, just like in here, cotangent theta can be written in the form of 1 over tangent theta as it is, because that's a reciprocal of that value. So now we can use that thing in here. So our left hand side shows in here, left hand side, tangent theta over, can we write on the cotangent, because we can convert that one into tangent to make it a same LCM. So when you're taking LCM of that bottom value, so that becomes tangent minus and that thing is same as it is. So as you know that is something in the division and then also that division, then that bottom value will multiply on the top. that becomes tangent square theta, and tangent theta minus 1 plus cotangent theta over 1 minus tangent theta. That value comes up. Because that's not similar, if we take negative values out, then top value will be negative 1 minus tangent theta plus cotangent theta over 1 minus tangent theta. That value comes up. Now the both LCM are the same, so we can take these LCM similar because they both are the same. If I remove that one and then use that thing, so now in here you can see that becomes 1 minus tangent theta in the fraction form, and that both top values gonna be the similar, tangent square theta plus cotangent theta. So while we are using that values, so what we can do with that? So because we need to make it that value a squared or something like that, so then we have to multiply and divide by tangent. So multiply and divide by tangent theta. So when you multiply and divide by tangent theta, that becomes tangent theta. You can say that this is cotangent theta minus tangent square theta, like that. When you multiply that one, tangent theta cotangent theta minus tangent cube theta over tangent theta 1 minus tangent theta. So now, as you know that tangent theta and cotangent can be written in the form of 1 over tangent. So that cancels, so that will become 1. So now in here we will use the same formula like that. 1, if I write down 1 cube minus a cube, then that becomes 1 minus a, 1 plus a square, like that formula we will use in here. So that becomes 1 minus tangent theta, and that becomes 1 plus tangent theta plus tangent square theta, and that be tangent theta or 1 minus tangent theta. So that value cancel with that. What remaining? 1 plus tangent theta over tangent theta. So these are dividing each value, so we can write down that thing 1 over tangent theta plus tangent theta divided by tangent theta plus tangent square theta over tangent theta. So 1 over tangent, that is cotangent, that is 1 and that is 1 cancel, so which is equal to right hand side. So this is our proof. I hope you understand that one. So now we are moving to the third one. They're also asking, can you prove it? Saying prove that tangent square theta plus cotangent square theta plus 2 equal to secant square plus cosecant square theta. So again we will decide our left hand side and we will prove to the right hand side. As you know that, before you know that, these formula, if we say that in a 1 plus tangent square theta, that value is equal to secant square theta, and 1 plus cotangent square theta is equal to cosecant square theta. If you need just tangent, then 1 goes on the other side, so that becomes secant square theta minus 1 equal to tangent square theta, and same as it is in here, cosecant minus 1 is equal to cotangent square theta. So now we are selecting our left hand side. Instead of that, we can put these functions, these formulas in there. So minus 1, minus 1, minus 2 and 2, that cancel. What's remaining? We already used these formulas. Remains only secant square plus cosecant square theta. As you know that secant is equal to 1 over cos and this is 1 over sine. So we can write down 1 over cos square plus 1 over sine square theta. Now LCM, both multiplies. So that value can divide by that. What's remaining? Sine square multiplied of 1. And same it is, that thing divided by that, we go cos square multiplied on the top value, numerator. And sine square and cos square equal to 1. So 1 over cos square is equal to secant square, and 1 over sine square is equal to cosecant square. So equal to right hand side. This is our proof. So now we are moving to the fourth question. They are asking evaluate evaluate sine 27 degree over cos 63 degree and whole squared plus cos 63 degree over sine 27 degree whole squared. We need to prove that thing. So what we can do with that? Sine 27 can be written in the form of sine 90 degree take away 63 degree, because 96 take away 63 is 27 and the bottom value same as it is, write it down, and whole power is a squared. Same thing we need to apply on the top. Cos 90 degree take away 27 degree and the bottom value comes as it is, sine 27 degree and whole power is squared. Now in here, which formula we will use? Just like in here, sine a plus, because there are negatives in it, so minus b, sine first angle cos of second angle minus cos of first angle sine of second angle, that thing for the negative, cos of a minus b, cos first angle cos second angle plus, if minus comes in cos it's gonna be plus, sine first angle and sine second angle. And one more thing, because we are using 90 degrees, so sine 90 degree is equal to 1 and cos 90 degree is equal to 0. So we have to apply these formulas in here to solve that question. So first we will see in here if we apply these values. So let's see. We need to apply first on the top. That becomes sine 90 degree cos of 63 degree minus cos of 90 degree sine of 63 degree plus, in here same as it is, cos of 90 degree cos of 27 degree plus sine of 90 degree sine of 27 degree. Now this value, as you know, the sine is, this is 1 and this is 0 and this is 0 and this is 1. If 1 multiply any value, that give you that value, cos 63 degree, and that becomes 0. Other thing, that 0, that become only sine. And this is 1 and this is also a 1. 1 square is 1, 1, that becomes 2. This is our answer. Now we are moving to the fifth question. They are asking to prove that cos of cos of 90 minus theta over sine theta plus sine theta cos of 90 minus theta is equal to 2, where theta not equal to 0 degree. So again we need to apply same function in here. So let's see, that become cos of 90 cos of theta plus sine of 90 sine of theta. Cos of 90 cos of theta plus sine 90 sine theta. So that become 0, that becomes 1. 1 time is sine over sine, that become also sine, that cancel 1, add 1, 2 equal to right hand side. This is our left hand side. We prove it to the right hand side. Now our next one is prove that again, because if you know the formulas, then you can easily solve these kind of questions. Secant minus tangent squared whole squared equal 1 minus sine theta and 1 plus sine theta. These are the value. So again we can select our left hand side. So secant theta minus tangent theta whole squared. And as you know that secant is equal to 1 over cos theta. Because you can see in here we need our answer in sine, no secant and tangent. So that's why we have to convert that values into, and tangent is equal to sine over cos. What is the LCM of that? 1 minus sine theta over cos of theta, and a whole squared. And as you know that a whole squared cos 1 minus sine theta whole squared, and a cos square theta. And as you know that cos square is equal to 1 minus sine square. You can write down in here cos square 1 minus sine square theta. So we need to write down in here 1 minus sine theta squared. 1 minus sine squared theta. So 1 minus sine theta and 1 minus sine theta, because that was a squared, so we can split into twos. In the bottom one, 1 minus sine square, what formula we can use in here? You can see, if we have a square minus b square, we can write down a plus b and a minus b. But in here we are using 1. Can we write down 1 square minus b square? Then we can say that 1 minus b and 1 plus b. Either any formula we can use in here. So we can use, instead of that thing, we will use 1 minus sine and 1 plus sine, and minus 1 cancel. What's remaining? 1 minus equal to right hand side. We have done 6 questions. I hope you like that video and understand. We will do some more questions afterwards. So if you need any help, please write down in the comments. Thank you.